If you've come here from part 1 of the title screen UI tute, then welcome back. In this tute, we're going to build a state-based UI system for keyboard and controller navigation. It should bolt onto pretty much anything though, so there's no need to watch the previous video at all. In the riveting world of UI systems, the most important thing is the font. So create a TM Pro text thingy and import the TM Pro essentials. Unity automatically creates a canvas for it with default settings for a CRT monitor in the 90s. So change the scale mode to scale with screen size and change the resolution to at least 1080p. Head to the Windows font directory and drag one into your Unity project. I went with Cambria Bold because of its high octane serifs. It turns out fonts are actually rocket science, so you'll need to make a font asset with TM Pro's Font Asset Creator. Set the Atlas resolution to 1024, set a minimum padding percentage of 10 to 12%, and set the sampling point size to auto. Hit Generate Font, check for any errors, and save it to your project somewhere. It's a good idea to duplicate the blue font asset thingy before we modify anything else because changing one means changing every instance of that font. Rename it to title screen font or whatever, and drag it into the title screen text material / asset field. Change the vertex color to black, and in the material pane, change the outline color to white with a bit of transparency and set a small outline dilation. Set the text to bold, stretch it in the y-axis and squash it in the x-axis. There's a couple of ways you can do the underline bar. You can draw one, 9-slice it with Unity's sprite editor and stretch it out. Or you can create two UI images, one black and one white, put the black over the slightly larger white and stretch that out. Either way works, but the 9-slicing method is probably better. Clean up the hierarchy by creating an empty object named title screen, group your title text and underline bar together, and parent it to the title screen object. Next, create another empty object named title ops and create text title options like new game, options, quit, and so on. We want them to be text and not buttons because, you know, this is a custom UI system. If you want to use buttons, you might as well use Unity's built-in UI system. Next, you'll need some sort of pointer. Something like the old school OG Final Fantasy games is good, but you could use just about anything. I drew this one for the RPG I'm making, so I'm going to use that. As with all pixel art or sprite images, you want to stay crisp. Set it to Sprite 2D and UI, single image, filter mode to point, and compression to none. Create a canvas image, drag the cursor into its image slot, embiggen it to your liking, and point it in the direction of the first option. Take a moment to admire how pretty it all is, because we're about to stare at code for the next 5 minutes. So the plan is to make a title screen manager named TS Manager that's mostly the UI state machine. It transitions between menu data states, which in turn have various option data virtual methods that control the UI functionality. So create a folder for your title screen scripts, create a TS Manager mono behavior, an option data and menu data mono behavior as well, and create a title states folder to hold the concrete implementations of the menu data class. Create a TS title script as the first menu that will hold our new game, continue, options, and quit menu items. Open up TS Manager and make it a singleton. Some people don't like singletons, but if they're good enough for Unity to build their entire multiplayer netcode system on, then they should be just fine for our tiny little UI system. I want to eventually hide the game title screen for some menus, so create a game object reference to turn it off when needed. We need to track what menu is currently open with a menu data current menu field. The TS Manager will pull from a menu dictionary of enum title menu keys and menu data values. Create the title menu enum with some menu names that are relevant to your project. You can either create a surrogate array to fill the dictionary or get all menus at runtime in the awake method. I'm going with the latter, but this approach can cause race conditions if you aren't careful, so if you're unsure, go with the surrogate array. We want to grab disabled and hidden menus, so pass true into getComponents, plural, in children. It's a good idea to disable all menus at startup, then transition to the active one on start. Next, head to Menu Data, delete all the crap in the middle, and punch out a public title menu's menu type field. If you want your menus to have a name, create a string menu header. Not all menus will use the pointer we created, so create a bool useCursor variable and set it to true. The help bar text menu stuff is optional. Menus hold options, so create an option data list named options. The concrete menu implementations will inherit from menu data, but the implementations themselves will handle their own functionality. We're basically going to use a command pattern for the state machine, but you could use interfaces if you really hate yourself. But interfaces did kill my brother, and they will eventually pay with their own blood when I get my revenge. For the time being, create virtual onEnter, tick update, move cursor, execute on select, and exit methods. A TS manager move cursor bool will be our kill switch for UI functionality, which will hopefully make more sense later. Tick update will be ticked in TS Manager's update loop and is responsible for capturing inputs. I'm terribly old and fussy about my lawn, so I refuse to use the new input system. Truth be told, I can't be fucked learning how it works, so I'm using the Boomer input system for now. We're going to handle keyboard inputs first to keep things simple, so generally we want WASD movement and E to select menu items, but you can make them anything you want. Create a button names enum with button names and a move direction button name field. Set to none. Basically, we poll for directional keys pressed and move the cursor in that direction. Call execute on select when E is pressed and set the move direction button name to up on W pressed, down on S, left on A and right on D. If you don't like class level fields, you can pass move direction as a parameter to move cursor. Move cursor switches on the move direction, and just like the TS manager tracks the current menu being displayed, the menu data class tracks the current option selected, the option data class, as well as the previous one. You could probably get away with just the current option if you deal with the option formatting up front. Our option data class is currently empty, but it will map all of the options above it, below it, and next to it where applicable. The switch statement jumps to the option mapped in those directions, kind of like exactly how Unity's built-in UI system works. So head to option data, create a string option name, bool is enabled, and use cursor attributes, and grab the options rect transform. Options are text in our system, so grab the TM Pro UGUI text reference as well. And most importantly, create a rect transform cursor pos for the cursor position. Next, create the option data map for the options, and I can see why editors drink. Grab the relevant references in the awake method. I'm not a huge fan of the command pattern because it seems like hard coding with a few extra steps. And in a way, it is. There's definitely room to improve this system with scriptable objects and dynamically propagating menus, but that adds another layer of complexity, abstractions, and other industry buzzwords that, if we're being honest... Oh, look, a strobe ant. In TS Manager, grab the pointer cursor thingy's rect transforms, so move cursor can move it to the selected option data's cursor position. Set the menu's game object to active on enter, which shows the menu when we transition to it. You might want to set a default option index on enter as well for things like cursor memory, etc., and send the cursor to that position on enter. Set the selected option to the default one on enter and set can move cursor to true so we can move the cursor. In execute on select, handle invalid options first, then just debug log the selected one for now. Head to TS Manager again to complete the state machine by creating a method called transition2, taking a title menu parameter. You can make this more generic if you want, or if you want me to do it, you can let me know in the comments. Grab the new menu out of menu dict. You can guard clause it if you really want, but shit is basically welded in place here, so I wouldn't bother. If this menu shows the header, then update the menu text and show it. Likewise with the cursor. And finally transition through the states by triggering on exit for the current one, setting the new one and triggering on enter. Tick the current menu update if not null and set the can move cursor kill switch check, or don't because we can do that in the implementation. In Start, transition to your title screen menu. Next we're going to work on the TS title implementation. It inherits from menu data and overrides the virtual methods as necessary. For most menus we use the base class functionality, which is what you want for virtual methods, but you can cram any bespoke menu functionality you need into the overrides. Save it, apply the TS Manager to the title screen object at the top of the canvas hierarchy, drag the game title text reference into the title text field in the inspector, drag the pointer into the cursor transform field, add TS title to title ops in the hierarchy, set its menu type, give it a name, and hide the annoying fields that aren't relevant. Add the option data script to the first option, give it a name, create an empty object child for the option cursor position, drag its reference into the option data script and make it a prefab so we don't have to do that all again. Next, go through and map each option's on up and on down fields to the buttons above and below it. To wrap the cursor around to the top or bottom, set the top options on up to the bottom and the bottom options on down to the top. I forgot to grab all of the menu options on awake for the option list, so you should probably do that too. It's like 2 AM at this point and I'm getting pretty bloody tired. The Boomer input system is deactivated, so head to the super intuitively placed project settings player active input handling and set it to both. After Unity has finished crashing, restart your project and give it a whirl. That pretty much completes part 2 of the tute. For part 3 we'll be polishing up the menu options, filling out the execute on select method and implementing controller support. If you made it this far, you're a bloody champion. Thanks for watching.